right, so our focus for this whole lesson, like I said, we started this before the test a couple days ago. We talked about arithmetic sequences. Now, you want to think about it this way. Last night, I watched 2 episodes in the sequence, put the food away, please, of This Is Us. I'm choking up just thinking of it. It's an amazing show. But if I wanted to get the whole series, that's all of the episodes contained. So the sequence is what order it occurs in. And we said that if we're talking about the sequence, we can generate the sequence using any 2 terms, but we usually use the first and the last. We say the last term is the first term plus the difference times n minus 1. But if I choose to use different terms, whatever terms those are, those numbers go in the same order over here. Okay? So we can use that to find n, we can use that to find d, we can use that to find any of those singular values. You can only find one at a time. And so we did that where we wrote the equations, and please make sure that when you do the equations, you always distribute and simplify. Okay? It's not a big step, just make sure you always distribute and simplify. We used it to find missing variables. We used it to find differences, terms, and that was the hardest one, to find the term, if you were given random things. So we said if you were given 2 terms, you just use those values in your formula instead of n and 1 and plug it through, finding the difference first, then the first term, then plugging it in to get the equation. Now, the reason why that's important is it all builds up until what we're trying to talk about here, which is arithmetic series. Now, a series, anytime we talk about a series in any form, the series is the sum of each of the terms, which is why a television series is the collection of all of the episodes, or a movie series. Same thing. Now, we have 2 different formulas, but they're really not 2 different formulas. All it is, the second formula, simply comes from taking the fact that we have something that tells me how to find a sub n. What is my formula to find the nth term? It was just up here a second ago. What is the formula to find the nth term? Right. So if I were to put this in place of this, I would then have 2 a's and the difference minus 1 times n minus 1. So they're the same thing. What I do is I use this one if you are given the first and the last term. I use this one if I'm given the common difference. That's all it comes down to. It's like, what do you have? What do you have helps determine what do you use. And this equation is a combination of your term as your formula for a single term shoved into the formula for the sum. Okay, so give you a chance to finish writing those down. And then if you would, please write down 6 and 7. You're going to have to be really, really careful with this stuff. It's all about reading the instructions to figure out what it is that you're looking for. For these next 2 problems, first thing it says is find the sum. Since I'm finding the sum, that means I'm going to use either that formula or that formula, depending upon what information you're given. But I'm given something else in those instructions. What else am I given in those instructions? Bless you. 16. What is 16 going to stand for? The amount of numbers. So which thing? Just the n. Just the n itself here is 16. So if I start looking at the problems, what do I know looking at what they gave me for number 6? The first term is 5. What else do you know? Good, the common difference is 2. Because we go from here to here, that's plus 2, and we keep that pattern. And guys, always, always, always check for as many terms as you have, because sometimes what works for the first one doesn't work when you keep going on. Maybe it's add 2, and then add 3, and then add 4. Maybe. Maybe it's plus 2 times 2, plus 2 times 2. There's all sorts of different ways that you can do this. So always check to make sure that pattern holds. So I have A, I have D, and I have N. Do we want to use equation 1 or equation 2? 2 makes the most sense. Can you use equation 1? Yes, but you have to find A sub n first. But if I use equation 2, all I'm going to do is plug things in directly as I see them. So we would say the sum, n is 16. The sum of the first 16 terms is n over 2 times 2. What is a sub 1? What is the difference? What was n? And that's it. Yes, you can use calculators.
Okay, good.
Please, at least say please. My goodness, aren't we bossy? Dylan, you need longer arms. Reaching. So figure out what that gives you. Not a trick question, just plug it in, see what you get. $320. We okay with that? On a side note, I don't remember exactly who the mathematician it was that came up with this formula, but he came up with it in like middle school. Because his teacher was tired of him always finishing everything so early and always being right and being a know-it-all. So she gave him an assignment. She said, okay, I want you to go back and I want you to add all the numbers from 1 through 100. So you know what he did? What's 1 plus 100? What's 2 plus 99? 3 plus 98? 4 plus 97? And how many of those is he going to have to go through?
50.
Why just 50?
Because it takes 2 numbers.
Because it takes 2 numbers. Beginning and end, beginning and end, beginning and end. So he only has to go through half of them. So 101 times 50 and done. So 101, I'm going to write it this way. So we're going to have 0, 5, 0, 5. Walk up to your teacher. I've just done it. That's where this formula comes from. So look at this. First term plus last term. And as I go through my terms working in from the back and the front, it's always going to give you the same thing. N over 2, because that's how many times you're going to have that sum. And always, either n or this sum will be even. So your answer will always be a whole number if all of your terms are whole numbers. Kind of cool, huh? Gosh, I might have been in elementary school. I need to look that up to see who it was and how old they were. But it was like really irritated by the... At least this was the story I heard. You know, it's on the internet. It must be true. Okay? Huh? All right, so I want you guys to try number 7. We're still sticking with the idea of n equals 16. have you, never mind. Dang it, I was going to have you all read out the answer at the count of 3, and we were all going to get the same number, right? 712. Okay, hopefully you're seeing that these are not difficult formulas. What is going to be difficult is knowing which formula to use and when. So if we instead take a look at the next problem, number 8, go ahead and write those down. Then we're going to need to figure out what is it that it's asking me for? What formula am I going to use? All right. So what is this asking me for? The sum. Are we doing 16 terms? No, this is separate. How many terms do we have? We don't know. So that's one problem right away. But this is what I do have. I have the first term. So let's list out what we have. We have the first term, which is, what else do we have? The difference, which is 3. What else? We know what the last term itself is, which is 39. So even though I don't know how many terms there are, I do know what the last term is. So if I want to figure out, because before I can find the sum, I have to have, required to have, no matter what, the n. So I have to find n. Whether I like it or not, you've got to find n. We do have a formula that ties all of these things together. Which formula is that? A sub n equals A1 So we start with a formula that has all of those pieces in it, with only one guy missing. Because I can't use the sum formulas, because that would have this missing and that. You just can't do that. Okay? So, the nth term was what? 39. The first term was? The difference was? And then we have n minus 1. There are a bunch of different ways to solve this, some easier than others. What can we do? Subtract 6. And then divide by 3. And had that been on the test, half of you would have missed that. Pay attention to how you solve these things. It's not a difficult step, not a difficult process. But because you have little steps, each little step opens you up for a chance for a mistake. Be careful. But hey, now I have n. And really it's up to you. Which formula would you rather use? The first one or the second one?
First.
I would go with the first one too, because if you have those pieces, it's a little bit less to plug in. So I'm just going to go back to that first equation and say the sum of the 12 terms, because that's what my n is equal to that number, 12, over 2, times, what is the first number? The last number? Evaluate. Plug it into your calculator. Tell me what you get. What do you get?
270.
Have I just completely and totally blown your minds? No? You did this last year, exactly.
Yeah.
Wait a minute, this feels exactly similar, because guess what? These are actually even the notes that I used for Algebra 2. All right, so, bless you. Go ahead and write down number 9 for me, please. Don't let this problem, bless you, frustrate or confuse you. What do the instructions say? Find the sum. So we already know that we're narrowed down to two formulas. Do not let the fact that there's a variable in here throw you off. That's okay. That n still stands for the number of terms. For example, let me give you a hint. If I were to plug 1 into this, what is 54 minus 4? 50. If I were to plug a 2 into this, what's 54 minus 8? 46. If I were to plug 3 in, guess what you get? 42. So they're saying this is the formula I use to generate this sequence. No matter where my series ends, find the sum. So what's the first term? What's the nth term? And it just so happens that n is just n. So do we have a formula that uses a sub 1, a sub n, and n? Yeah, we do. So the sum of the n terms, what am I going to put in this? N over 2 times, using what we have up here, 50 Now, we're not going to get a single answer for this. We're not going to say, okay, the sum is 35, which it wouldn't be because all the numbers are bigger than that anyways. But we're not going to have that. We're going to have some expression. So we do want to simplify it as much as possible. What is 50 plus 54? 104. Now, we do need to distribute this. Distributing a half means divide both terms by 2. So what is 104 divided by 2? 52. And then there'll be the n, and then minus 2n squared. So that is the formula for the sum. And we will be using this to solve some equations in a little bit.
Couldn't you figure out n though, because you displacement and a common difference?
No, we don't, because we don't know when it stops. You see these 3 dots right here? Means it just goes on, and we don't have a specific stopping spot. This here gives me the entire formula for each and every term. Okay? All right, so we are going to do number 10 when we get back from lunch, so please go ahead and write problem 10 down for me at least. So what we're looking at right now is we are talking about finding different things. Now, we are looking for n here. Excuse me. Ooh, cookies in the throat. Okay. We're looking for n in a series where we're giving these pieces of information. So I have the first term, I have the difference, and I have the sum. Is there a formula that uses just these guys and n? Yes. Which formula is that? S sub n equals n over 2 times what? Well, which one of them?
2a1.
This one we'd need the 2a1 plus d times n minus 1. I mean, you could technically use the other one, but you'd have to find the nth term first. And since we don't know what n is, that's probably not the best choice. Okay? So let's plug into this equation what we do know. So what is the nth sum? 246. We do not know what n is, so I have to keep it like this. What is a sub 1? What is the difference? We still don't know n. So this is what I have. This here is an equation. This can be solved. So that's what we're going to do. We are going to solve this equation. So let's simplify it. What should I do first to simplify this problem? Yeah, 2 times 4, which is 8. And distribute, when we distribute, we would have 3n minus 3, making sure that you actually distribute. Okay? All right, so when I combine my terms, I will 246 is n over 2 times, what do we get when we simplify this? 3n plus 5. Bless you. One more. There you go. All right, so in order to solve this problem, the thing is I'm trying to get this to a position where I can solve it. And right now I can't, not with these parentheses involved. So we have 2 choices. I always want you to think about this. Either if both of these 2 numbers are even, distribute the 1/2. Are both of these 2 numbers even? No. If even one of them is not even, get rid of the 2. How can I get rid of this 2? Multiply by 2 on both sides. So what is 246 times 2? And then on the other side, when I distribute, what will I have? 3n squared plus 5n. $246 times 2 is not. It's $492. Because it's less than 250? That's okay. All right, how do I solve an equation that has those types of pieces in it? Subtract 492 because it's got to be equal to 0. So 0 is 3n squared plus 5n minus 492. Now you have a couple of options here. What are the different ways that I can solve this? Factor. Do you know another way? Quadratic formula. And then one that we haven't done because we haven't had calculators. Graphing. But hey, guess what? Yeah, the x-intercepts, the zeros. Do we have calculators for this? All right, so let's go through and let's try to do this with graphing. Because, hey, I'm not trying to make you factor 3 times 492. It's not that hard.
Isn't it all over 2a?
Did I just write 2? Yes, thank you. All over 2a. Much obliged, my dear. So I'm going to go to my y equals, and I'm going to type in that equation. Okay? A little bit closer. And then,
Could we type in the original equation and just find that for the interception of 246?
you could, but this is actually going to be easier.
Okay.
So I've got my equation typed in here. What I'd like you to do is go to zoom, and then you're going to do 0 for zoom fit. And that'll at least get us started. Yours might look different than mine. It might, here, let me actually start to where it would have been. You probably started with something that looked like this, which isn't anything. Then zoom fit by doing a 0. And what that's going to do is it usually tries to make sure that you can clearly see the curve, the bottom of it, at least 1 0. Now, that's a little hard to see, so I'm going to hit my trace button, and I'm going to move this guy closer. Well, actually, no. I'm going to do zoom in. There we go. I wanted to be able to move it that way. Or, no, I want to zoom out. Sorry. What the heck, Augsburger? Pick something. And I'm going to zoom out so that's in the center. Okay. So, all right, here, I'll walk through it again for you. Okay? So do this with me so that we're all on the same page. Everybody do zoom 6. You shouldn't have anything on your graph because the graph is completely out. Okay? So now zoom 0 for zoom fit. And what it'll do is it'll try to smoosh that graph in so you can see as many of the characteristics as necessary. Okay, are you using one of my calculators?
Yeah.
All right, if you're using one of my calculators and you're getting an error, what I need you to do is do second y equals, and what's happening is your plots are turned on. So you need to make sure those are turned off, so go into it and then hit enter to get it to turn off. Okay? Yeah. Because this is used for my stats class, and if your plots are turned on, it doesn't always let you graph. Okay, so if you're using one of my calculators, always go there first. Okay? Now go back, zoom stat, zoom fit. Or zoom 6, zoom 0. Now what you can do is just hit the zoom button. I'm going to zoom out so I can see a little bit more. And you can either leave the cursor there or wherever you move the cursor. It's just like having your cursor on, or even you're doing those spread things on your cell phones. Wherever that center point is where it's going to spread in or spread out. So I'm going to zoom out right at that point. Now I can see it. I'm going to show you a couple of different ways to do this so you can choose. Now I'm just going to do second calc, go to my 0, point on the left, point on the right, and enter. And what is my solution? 12. Just give me a second. Another thing that you can do, are you ready? Because we're talking about number of terms, and the number of terms has to be an integer, you can go second graph for your table. And all you're going to do is you're going to scroll through until you see a 0. Look, there's your answer, 12. Or Dylan made a good suggestion. He says, hey, I have a number here, and I have an equation here. If you wanted to, you could put that number into y1 and that equation into y2 and look for where they intersect.
What about the other 0? Would you just not use the negative?
Well, you wouldn't use the negative because you cannot have a negative number of terms. Okay? Olivia, I'll be with you in a second because we're just about done here, and I'll see what the issue is. It's okay. It's okay. We'll figure it out. I have several options. All right. So we graphed. And in graphing, we found that it was 12 terms. Okay? You could have factored. That's perfectly fine. But we're only going to use the positive answer. Because we cannot have a negative number of terms. Okay? You understand what I'm talking about? All right. So what we're going to do now, I'm going to give you guys some time in class. What time do we have? 35. Holy crud, we have a lot of time. Okay. So I'm going to give you guys some time in class, and here is your class work. I don't have, no, one second. I don't have enough textbooks for everybody. I do have 7. So I will put the textbook also up on the screen up here. Or if you would like to share textbooks and work together, you may do that.
Can I get a picture of it on my phone?
That's fine, but I do not want to see anything but that. I'm going to give you guys a second to write that down. Write a puzzle sign.